Hello, my name is Amy Cummins Hawk, and today I will be presenting my data analytics project where I explored three main questions. So, the first one was cholesterol and coronary artery disease, the second one was vitamin D and age, and the last one was hyperthyroidism and body fat. So, first, we are going to look at my cholesterol data set, where I had information such as age, gender, and there was cholesterol measurements like total cholesterol, coronary artery disease, LDL, HDL, and triglycerides. And I also did make some categories such as age group, risk category, risk level, gender label, and HDL status. I also made some pivot tables to explore cholesterol patterns. I made a couple such as showing average cholesterol levels, levels in people with and without CAD, and breakdown of LDL by age group. So these pivot tables helped me understand where the biggest trends were for building my dashboard. And I also had the corresponding charts. So then on my cholesterol dashboard, I have 4 KPIs. The first one is population risk, which is 48.58% of the patients present with total cholesterol levels fall into the borderline high or high category. So this indicates a big baseline of cardiovascular risk. My next one is LDL cholesterol, which is the average LDL level is 126.76 in patients with CAD compared to 108.8 in patients without CAD. And my last two are the gender disparity. So 32.5 of male patients have low LDL compared to only 9.55% of female patients. So this identifies males as a significant risk factor for high levels of LDL cholesterol. So next is my charts. Firstly, I have the count of age by risk category pie chart. The distribution of cholesterol risk categories is nearly even, with 51.42% in the desirable range and a combined of 48.58% in the other two. So there was 27.44% in the borderline high and in the high category 21.14%. So this quantifies the scale of the population at risk. My second chart is the average of total cholesterol by gender and CAD bar chart. So this chart provides visual confirmation of the KPI data. It clearly shows the higher average cholesterol in males without CAD and lower levels in CAD patients. My third chart is the sum of LDL by age group and CAD stacked bar chart. So the LDL levels peak in the middle age, around 45 to 59 demographic for both patient groups. So this trend identifies midlife as the period of the highest LDL concentration. And my last chart is the average of total cholesterol by age group and CAD. So the middle age group contains the highest numbers of individuals classified in the high and very high LDL risk categories. So therefore, in conclusion, while high cholesterol is clearly linked to CAD risk, our most important finding isn't just that who is at risk. So the data reveals that middle-aged adults and men show the highest levels on untreated black cholesterol, and I also have slicers at the bottom for interactivity. Now for my vitamin D data set, I had information such as age and vitamin D levels. I also made some more categories in such as age group and vitamin D status. I also made more pivot tables to explore the vitamin D patterns. I made a couple such as showing average vitamin D levels across all age groups and the count of people in each status category. So these once again give me valuable information for building the dashboard. So on my vitamin D dashboard, I have 3 KPIs. So 43.26% of the population has vitamin D levels classified as deficient, 56.11% fall into the insufficient range, and only 0.63% have sufficient levels. Together, this means that over 99% of the population has suboptimal vitamin D levels. So next is my charts. Firstly, I have the status count by age group and status category stacked bar chart. So this chart visualizes the 3 KPIs, clearly showing the sufficient segment is almost non-existent, and deficiency and insufficiency dominate the population. My second chart is average vitamin D by age group bar chart. So the bar chart shows a surprising trend where vitamin D levels increase slightly with age from younger to older adults. So this challenges the assumption that older adults have the lowest levels. And my third chart is the status category, age, and vitamin D scatter plot. So this trend line here is almost flat, proving there is no strong correlation between age and vitamin D levels in this data set. So in conclusion, the data reveals that vitamin D deficiency is a widespread issue affecting virtually everyone, regardless of your age. Now for my hypergism data set, I have information such as age, gender, hypergism status, and body composition measurements like total body fat ratio, BMI, weight, and height. I also made some more categories such as age group and BMI category. And then next, I also made pivot tables to explore the patterns. So I made a couple, such as showing average body fat ratio by hypergism status, weight distribution across different BMI categories, and body composition trends by age group. And they have their corresponding charts. So then it helps me to build the dashboard. So on this dashboard, I have the two KPIs. So there's the body fat difference. So people with hypergism have a 4.03% higher average total body fat ratio compared to those without, and 55.56% of the patients with hypergism fall into the obese category. So next is my charts. Firstly, I have the average of total body fat ratio by hypergism bar chart. So this bar chart clearly shows the visible difference in body fat ratio between people with and without hypergism, which confirms the KPI finding. My second chart is count of age by hypergism and BMI category, a stack bar chart. So this stack bar chart shows that the hyperthyroid group is dominated by obese individuals, while the normal thyroid function group shows a more balanced distribution across weight categories. And then my third chart is the average of total body fat ratio by age group and hypergism. So this demonstrates that the pattern of higher body fat in hyperthyroid patients is consistent across all age groups from younger to older adults. So in conclusion, the data reveals that the hypergism is consistently linked to higher body fat across all age groups, with more than half of the hyperthyroid patients falling into the obese category. And lastly, I have my slicers at the bottom right for interactivity. That is my project. Thank you.